I am Mrs. R. Suguna, PGT Physics from KVAFS Avadi. Now I am going to explain one of the very important, very simple activity, but it is an important and very interesting activity too. And this is meant for 9th standard and 11th standard children actually. It is this apparatus, what you are seeing here, is called Newton's cradle. And with this we can explain the law of conservation of linear momentum and also the law of conservation of energy, right? Now this apparatus consists of, see, 7 bobs, identical bobs, and these bobs are identical in every respect. Both are all are having same mass and same material and same radius, etc., right? Now what I'm going to do here is I am going to give some actually momentum for the first ball. Momentum, that is velocity, you can say velocity, that just by raising it. So now it is having a potential energy. If I leave it, then it will be converted to kinetic energy, and hence the ball gets some velocity. With the velocity, it gains some velocity, and now it is colliding with this ball. Okay, when it collides with this, then second ball it is, right? When it collides with second ball, then you know that both are identical in every respect, mass are same, therefore their velocity, this second ball is at rest now, right? But what happens when it comes, when I'm leaving it, it actually collides with some velocity, and now what happens, because both are of same mass, you know that because of collision, when they collide, their velocities get interchanged because of their masses, because of equal mass, right? Therefore the velocity will be transferred from second to first to second, second to third, third to fourth, etc., last up to seventh ball. Seventh ball gains some velocity, and hence it gains some momentum, right? Therefore now this system here, you know that law of conservation of momentum says that for an isolated system, here this is an isolated system, okay, so it is a system of 7 bobs, right? Therefore the total momentum is conserved. That is, here the total momentum before collision is equal to total momentum after collision. That is what we want to show here, right? Therefore now you see here I am leaving this, therefore it gets some velocity. Now you see, and therefore that, see, it is before collision, let the mass of this bob be, yeah. Now, and if I leave it, then if I release it, then what happens, it gains some velocity, therefore its momentum will be mv. Therefore with the momentum mv it actually collides this, okay. Now the velocity is being transferred, therefore now the second last ball, the velocity is transferred up to 7th ball, and now the 7th ball now gets some momentum, okay, and hence you see here if I leave, it goes there, see this one. Therefore the momentum before collision is equal to the momentum after collision, okay. Therefore this is nothing but law of conservation of linear momentum, right? Now what I'm going to do, I'm going to take 2 balls out. When I am giving momentum to 2 balls, see 2 balls I have taken, therefore its momentum 2m, mass is 2m, and into v, the velocity it gains here. If I leave, it gains a velocity, let it be v, therefore the momentum is 2mv. Therefore this is before collision, 2mv means after collision should also be 2mv, okay. Let us see whether it is applicable here. So see here, yeah, see 2 balls are moving away. So momentum before collision is equal to momentum after collision. Okay. Next let me take 3 balls. Therefore 3m into v before collision. After collision should also be 3m into v. Okay. Therefore write, you see here, 3m into v. 3 balls are going together, right? Next one. Okay. 4 balls. Okay. So 4m into v. After collision should be 4m into v. Okay. See. 4m, yeah, see 4 balls are grouped together, right? Therefore momentum before collision 4mv, and momentum after collision is also 4mv. Then 5, see 5 balls are grouped together, right? So this is an excellent actually activity to show the law of conservation of linear momentum, right? Okay, now what I'm going to do, see, I'm going to give the momentum to the first ball, that is from right to left. Now at the same time, I'm going to give momentum, that is a velocity momentum, to the seventh ball from left to right. Okay, therefore that is momentum, with the momentum mv, it is going to collide this second ball, and with the momentum m, but in which direction? Right to left. But here it is going to collide with the sixth ball from left to right. Okay, therefore once again the momentum will get, see here what happens, the momentum before collision should be equal to the momentum after collision. Therefore momentum before collision is from right to left, it is mv, left to right also it is mv. So after collision, let us see, the same thing should be there. So just you leave it. Let me go to, see, the same height I am taking, so that now I am, see, I am leaving it. See, it says that momentum before collision, see, is equal to the momentum after collision. Right to left mv and left to right also mv. Okay, so in every whatever we have seen, everywhere it is confirmed that what is that, momentum before collision is equal to momentum after collision. Therefore law of conservation of linear momentum is proved. Okay.